The next function is Swimwalks. This will use walk. It takes a number of steps and a number of trials. It begins by creating a drunk, for some reason named Homer. It then places the drunk at the origin, in this case 0, 0, initializes a variable that will be used to keep track of how far the drunk has moved in each of the trials. And then for t in range number of trials, it creates a new field, adds the drunk to the field, and then calls walk, gets a number of steps, and appends it to distances, which eventually it returns. You might be wondering for a minute where this came from. We hadn't talked about that before. Number of trials, which we're iterating over down here. The function Swimwalk calls walk to simulate one walk. Because we're making a bunch of random choices during the walks, we don't want to infer too much about a typical walk from any one walk. After all, we could have one walk in which the drunk just oscillates back and forth across the origin. By running a large number of walks and then aggregating their results, we can get some inclination, some indication of what a typical walk might look like. We'll do that in Drunktest. The number of trials, I've just arbitrarily here, I could have made it a parameter, but I've included the number of steps. So we'll take walks ranging from 10 steps to 100,000 steps. For each of those, we'll call Swimwalks to get a distance, and then we'll print three things: how far it was, that is to say how many steps were taken, the mean distance, because remember we're running multiple trials, and the maximum and minimum distances to give us some insight not only into what the average is, but what the variance is.